Objective of experiment 4 is to use linear thread to investigate the Newton's second law of motion. The introduction or the theory of this experiment is linear motion is a motion of one dimension when the object is moved in straight line. When the object travel or move in straight line, it will change the time. Newton's equation of motion that we will use and apply is F equal to ma, which m is a mass of the object and F is the force. When m2 is releasing, both objects will accelerate. The two masses will have acceleration a of the same magnitude. They have the same magnitude because they are connected as a single system by an unstretchable string and massless string. An analysis of the motion, assuming that Newton's law of motion are correct, is set out below. The free body diagram above shows that there are three forces acting on M2. The force from the contact of the frictional surface pushing up on M2 level T. The contact normal and the gravitational force cancel each other, meaning the total force acting on vertical direction on M2 is equal to 0. Then, it shows that only two forces acting on M1, namely gravitational force W equal to M1G in downward direction, and the tension is that pull M1 up. From this experiment,
as the apparatus has been installed in a full set, so the linear attract, we will start with the power supply and the pump. We switch on off both it, and then the air of the linear attract will let blow for a few minutes through the track. Okay, the track, we do this should be balanced by we adjusting the screw on the legs of the track. We want the glider to keep static when it let go. Means we switch on the pump so the air blower will let the glider move. Hanger that we want to put the masses on it had inserted at one end. After the bench pulley, we will tie the string on the top of the hanger, like it shapes like the hook, so we will tie on it. And then also they provided a flag or a guide that we have to put on the top of the glider. Next step is we have to measure the mass of the hanger and also the length of a flag or guide that we apply on the top of the glider, and then we will record the result. After that, the string will attach. Actually, the string will attach mean that we tie to the end of the hanger. The top of the hanger shapes like hook, so we tie on it, and also on the end of the glider. For starting the experiments, we will start with the mass of 20 grams we place on the hanger, and then the string will be put over the pulley. Okay, the bench pulley. Okay, so the glider being positioned exactly before the photo cap, before we have to let it go. So the glider been released and the time had recorded. The glider means that the glider had released after we turn on the air blower. So the glider will go forward, and then the time that we recorded by the photo kit, we have to record it on the table that provided, table of result. And then this experiment have been repeated for 2 more times for each message that we apply on the hanger and the glider that will be released and the time that will be taken will be recorded to obtain the time average. So the procedure has been repeated for 4 times with 20 grams of masses we added to the hanger. So there will be after the 20 gram of the hanger, we apply the 20 gram again, so will be the total of the masses will be the 40, and so on. 20 gram, 40 gram, 60 gram until 100 gram. We added about 20 grams. Denoted by the instructor and also provided in the book that to avoid the masses from crashing to the floor or scattering, the glider will catch or stop by a hang before the hanger reach the floor. Means there was someone who's power on the pump, and then there were others, someone who in the middle of the linear track will stop the glider in the middle by a hang, force the glider to stop by a hang or catching glider also what on what to do to avoid the hanger of the mass being crashed into the floor and scattering.
Now, let's take a look at the result of the experiment, shall we? Here we have the results and the data that we have collected from our experiment. Now, the analysis graph and calculation. We have plotted a graph of wake force versus acceleration. This is what the graph looks like. Based on our analysis, the graph tells us that the force is proportional to acceleration. That means it is proportional to the Newton's second law, which is acceleration is proportional with force and inversely proportional with mass. Now, there could be some error during our experiment. There could be a human error while conducting the experiment and some measurement error due to the surroundings.
Newton's second law is a quantitative description of the changes that a force can produce on the motion of a body. It states that the time rate of change of the momentum of a body is equal in both magnitude and direction to the force imposed on it. This experiment allows us to create a graph of weight force versus acceleration, which shows that as the weight force increases, the object's acceleration also increases.
The conclusion of this experiment is Newton's second law of motion can be discovered by using linear track, and this experiment allows for the analysis and determination of the tension, weight, and acceleration motion. And the duration will shorten as the hanger masses slots increases.
Objective of frictional force is to determine the coefficient of static friction of different surfaces. Introduction or theory of this experiment is force and velocity is a vector quantity that have the direction and magnitude. Velocity is a speed in specific direction which traveling the object, and force is it when the object accelerates or undergoes a change in velocity. If the body is rest or in equilibrium, the force that acting on the body is zero. Gravity also exists in frictional force. Gravity is a force that attracts the two mass together. The gravitational force that acts on an object is approximated as Fg equal to mg. M is the mass of the object and g is the gravity of acceleration. The magnitude of gravitational force is exerted on an object is referred to as its weight. Normal force is a contact force that acts in normal direction or perpendicular to the surface between two objects. Frictional is the force that resists the relative motion of one surface in contact with another. There are two types of frictional force. One is static and two is kinetic. Static friction is the friction that acts on an object that is in a rest. Meanwhile, kinetic friction is the friction that acts on moving objects.
Based on our objective of experiment, which is we have to determine the coefficients of static friction for different surfaces, which is rubber surface and also the non-rubber surfaces, non-rubber surface. And by the graph that will be plotted in the first, we can find also the calculate the coefficient of static friction by using the two coordinate that we choose. Also here the formula coefficients of static friction that we obtain from both surfaces, from the calculation I mean. I will define that the coefficients of rubber surface is 0.60 is greater than the coefficients non-rubber surface, which is 0.2 and 0.24. So we can highlight in here that coefficient of frictions actually influence the friction of the object. Means, for my opinion, I think means more high the value of coefficient that we gain. So we got more frictions on the object.
Based on the results of this experiment, the non-rubber surface have a greater coefficient of static friction than the rubber surface. The plotted graph showed that the coefficient of static friction of a non-rubber surface is higher than the rubber surface. Though this experiment may have a few errors that are due to the carelessness and parallax error during conducting the experiment. In order for us to minimize the error, the observer's eyes have to be perpendicular to the spring scale to avoid reading error. Other random error that can be found are caused by the uneven surface of the table that we used. This error can be prevented by measuring the spring scale numerous times and averaging the results.
The research being done on Hooke's law using the suitable apparatus and the objective of the experiment was achieved. Hooke's law is considered a spring block system on a frictional surface. When an object has a friction, we also need to include the calculation of the friction. According to the experiment we performed in the lab, the static friction force is inversely proportional to the normal force. The average static friction force rises together with the normal force. After plotting the static friction force Fs against the normal friction F, it thus displays a linear graph. And this lab demonstrated that our hypothesis definitely obeys Hooke's law. From the experiment, we are able to identify the accuracy of Hooke's law, calculate the total energy absorbing in the spring. Next, measuring the stretching produced by different masses added to the spring. And lastly, we are able to test the elasticity of a spring.